So I'm super excited to be here today. Both to you guys at home in your pajamas, I was one of you yesterday morning, and to everyone here in the room as well. This is actually my first ever wastewater conference, so try not to boo and hiss at me because I am coming from the drinking water side of things. I know. But yeah, it's really great to be here on the dark side of the force, because as a microbiologist, you know, drinking water, you do too much of a good job and you've not got a job anymore because you've killed everything. But here on wastewater, you guys love your microorganisms, so it's really nice to be here and be chatting, and everyone's been so friendly as well since I've been here. So what I'm going to start off today is I'm going to get you to put your hands up to a series of questions. Normally I would get you to stand up, but everyone here in the room today, I think it's a bit early in the morning. You're not hungover because I saw a lot of wine left over last night. But I don't know, I'm getting a bit of a grumpy feel this morning, so I'm not going to make you stand up, I'll just put your hands up. So what I want you to do is put your hand up if you think you know what this is. And I'm not gonna pick on people to try and guess what it is, so put your hands up if you think you know what this is. And if you're at home, you can just write down yes or no if you so wish. Okay, so it's under a scanning electron microscope, and this is actually what a biofilm looks like. So our first talk today, our keynote talk, was speaking a lot about biofilms, and this is what a biofilm actually looks like. And you can see there the white bit in the middle, that's the biofilm itself, so it's quite patchy, it's not very uniform like it would be if it was a chemical covering or something like that. So this is what a biofilm is. And my next question for you today, I'm going to go through some of these different environments, and I want you to put your hands up if you think that this specific biofilm was found from one of these places. So first up, we've got someone's mouth. Put your hands up if you think that this biofilm on the screen was from someone's mouth. No? No takers for that one. So biofilm can actually be found in the mouth, and if you've got any children who sort of complain about brushing their teeth in the morning, and they're like, well, I've not been snacking overnight, why have I got to brush my teeth at night time, and then again in the morning? Well, it's because of this biofilm. So these microorganisms, you're not removing them all from your mouth at night time, and they're there, they're growing, they're reproducing, and they're forming this biofilm. So bad breath, sticky or gross teeth, it's from this. Next up, how about this? So we've got like a rock pool here underneath that one. Put your hands up if you think that this particular biofilm has come from the rock pool. Maybe a nice place by the coast, maybe South Wales, you're going crabbing. We've got a hand up, we've got some brave people coming forward and being like, yes, maybe it's from there. So next up, we've got someone's kitchen. They're taking a glass full of water to go and drink their drink. Put your hands up if you think that this biofilm is from that as an application. Okay, a couple more. And then finally, we have got the world's apparently most pristine wastewater treatment plant that I've seen in my entire life. Put your hands up if you think this particular biofilm is from this wastewater treatment plant. A lot more hands for that one, I think. And quite a few people quite quiet and quite shy. It is still early, So biofilm can be found in all of these different environments. But this particular example, and maybe it was a bit of a hint with the credit at the bottom left, so this is actually a drinking water biofilm. So this is coming from the tap water one. So it's not that exact kitchen tap, of course, but yeah, this is from the surface of a drinking water distribution main. So that's where this biofilm is found. So what actually is biofilm? I like to think of it as like a sticky spider's web that can be found on all sorts of different surfaces where that microorganisms can be. This EPS, this extracellular polymer substances. And this sticky spider's web, it sticks to all of these microorganisms. The microorganisms themselves are producing this sticky spider's web. It sticks nutrients to it, food sources, other microorganisms, and yeah, it's a big mess, basically. That's what a biofilm is. And like I said, a bit patchy, a bit here, a bit there, not uniform in any way. So what am I talking about here today? Why am I here with you? So I'm here today to talk about a probe called the SENTRY device, which is a technology that I'm working with at the moment. So the plan for this probe is you put it in a water environment, so you submerge the probe. So in this instance, for example, it's some very nice looking wastewater. And normally when you're putting anything in wastewater, it's gonna grow this biofilm on it over time. It's gonna get gross, it's gonna need cleaning, it's gonna need maintaining. But the probes that I'm working with, they're actually designed for this biofilm to grow on the surface of the probe itself. So that's what they're intended to do. So you don't have to take it out for cleaning. You don't have to take it out for maintaining. You just put it in, and when the biofilm is growing on it, that means it's working right. And you might think, oh, is there too much biofilm that's growing on it over time? But naturally, the biofilm it sheds as part of the biofilm maintenance, formation, maturation process. It just sheds over time, and new biofilm grows. So what is it? Why are we putting these probes that don't need cleaning? So normally when microorganisms are reproducing, they produce electrons, and these electrons are sort of lost to the environment. But this device, a bit like a microbial fuel cell, it collects those electrons, it quantifies those electrons. So I've got another member of our team in the audience here, Tom Williams over there. Yep. So he quite often describes this as like a Fitbit for your biology, because it's monitoring the microbial activity, the reproductive rate of these microorganisms, and whatever water system that you're putting this SENTRY probe into. So what can the installation actually look like? So I've actually got a probe down here, so I'm just going to go grab it so you can see it. So this is the probe itself, so it's actually quite small. It's really, really simple to work with. So I'm coming from a background where, I've used devices such as flow cytometers, AOC measurements, ATP measurements, and so on. They normally require, reagents, calibration. They're normally quite, they're fine once you get the hang of them, but to begin with, they can be a little bit tricky, especially if you're intending for people like operators to be using them. But with this probe, you literally put it in the water, and as long as it's under the water, then it's all happy days, it's all good. So at the moment, the projects that I'm working with, we generally have a control panel or 2 control panels on site, so that's the bottom left. And then we have between 2 and 4 probes connected to these control panels. And the control panels use a SIM card to get the data out there to our dashboard that I'll show you in a second. And that's how they work. It's really, really easy. It's a plug-in-and-play system. If they do ever require any type of cleaning, we have a really, really strict and stringent cleaning monitoring process that involves getting a bucket, filling it with sludge, putting the probe in there for an hour or 2, and then putting it back in the sludge. Really, really high-tech process there. So that's what the installation process likes. It's literally a control panel and a couple of probes. You plug it all in, and then you go. We're also looking at sort of battery-powered applications, solar power, that kind of thing, but the projects that I'm running at the moment were all sort of plugged in on power on site mostly, but we're really looking forward to sort of expanding in future. So what am I actually trying to do? I'm really trying to look at what the microbiology in these different water environments is doing. I really find that a lot of the parameters that we're kind of consented on, they are almost like estimating what the microorganisms are doing within sites, within treatment processes and so on. But I think with the technology that we've got today, we can kind of go above and beyond that. And we can start looking at what the actual microorganisms themselves are doing rather than just assuming what they're doing based on other parameters. So that's what I personally am trying to do with it. But what does that mean for actual water companies, water utilities, people who are going to be using these probes, and industrial applications as well? So these are just a few case studies. These are my key sort of areas that I'm focusing on with my projects right now. The first one is the area of compliance, of course, very important. So if you have a probe on the inlet to the site, you have one on the effluent of the site, you can see what's coming into the site and sort of what's leaving the site. How is the site coping with the microbial loading it's getting? So this is particularly useful. I've got a couple of sites now that are like, they're rural sites, they're unmanned, no one's based there, and especially during COVID, it was really helpful to have these devices on site because whether it was operations or whether it was innovation, they could be at home in bed in their pajamas if they wanted to, looking at our dashboard or logging into SCADA and seeing what the site was actually doing itself. So it's really helpful for that. But also we've been using it on a few sites because they've got some concerns with trade effluent. So the trade effluent at the moment is monitored with grab samples, which don't necessarily capture the full extent of the problems that they're experiencing with their variable loads coming into the site. So in this instance, they're using it to go back to the Environment Agency and say, look, these are our normal loading. It's all normal, all on the inlet. This is what we normally have on the effluent as well. And then suddenly we're getting this massive spike, which is abnormal. And the site hasn't been able to cope with it, but it's just because of this loading that we're getting on the influent. So yeah, that's the compliance piece. I think there's a lot of interest there. So that's one of the key sort of applications that I'm working with. Oh, so this is a picture of the dashboard, and you can come over and have a chat with me. I've also got a poster in the lobby. Just come over and have a chat. I'll whack out the laptop and show you this if you want. So this is what our dashboard looks like. It's super, super fancy. And these are some examples of an influent where there's been like a toxic shock event. So this was something coming into the works that's killing off all the microorganisms. But you can have the opposite happen as well. So you can have massive spikes in microorganisms. There were a few incidences, especially towards the beginning of lockdown, where it was very sad to take a moment to pause and reflect. But a lot of beer was thrown down drains. A lot of milk, a lot of beer thrown down drains. And that causes massive growth in microorganisms as well. So we have things like high alarms, high alarms, low alarms. But also I'll be emailing and saying, just so you know, that specific site that we're working with, something's going down on that site. Just making sure that you're aware of that. You might want to check the dashboard because something's happening and I don't really understand what's going on. So yeah, really helpful. And yeah, this is where some microorganisms are getting killed off. And the other big application that I wanted to chat with you a bit about today, because I think it's really, really exciting, is this piece around energy optimization. So a bit like how a motion-controlled streetlight turns on and turns off depending on whether you're around or not. It's a similar idea to that. So you can turn off bits of the plant when the microbial loading is low. So this specific site that I'm talking about, we have a probe on the inlet to the bath and on the outlet of the bath. And we turn off the blowers, so we turn off different units of the bath when the microbial loading to the site is low, to save a bit of energy to the site, because obviously the blowers, they take up a lot of energy to use them. So in this specific site, by doing that, by turning off one unit, maybe 2 units of the 5 that we've got on site and during these periods of low loading, we're looking at 10 to 20% energy saving, which is a lot of money, but I think also in terms of the drive to net zero energy, I think it's really important, working towards those environmental goals as well. So we're taking those first steps, I think, into seeing what we can do and how we can use this to help companies sort of achieve those goals that they've got. And that brings us on to sort of where the trials are that we're running at the moment. I think it really, really varies based on the specific site and what their problems are, you could say, depending on what they want us to do with the probes. And if you've got any sites and you've got any problems, feel free to come over to me, tell me all your problems. I'll act as your therapist and come up with maybe some solutions. I'll have a think on it and maybe think about how I could work with you to try and solve some of those things or help you with some of those things. So I started off doing a lot of the sort of water company sites, mostly based on the utility side of things. Actually, we've had a lot of interest from some industrial applications as well. So I didn't even realize, maybe that's me being naive and everyone in the room already knows that, but I didn't even realize that paper manufacturers actually treat their own waste. So I've got a site visit next week, actually, to a really cool paper manufacturer, and they make coloured paper. And you should see their effluent tanks. They're like rainbow unicorn tanks. The effluent is like bright green, bright pink, like circles of a tree, depending on what colour dyed paper they'd made that day. So for them specifically, it's all about visibility and having that online aspect, the real-time aspect. That's why they're so interested. We've also doing some work with the Scottish Smart Canal System on the catchment side of things. So that's all about, is the water quality, is it good enough to go in, to do your wakeboarding and so on. So yeah, really looking forward to doing more applications in the catchment side of things, or maybe even in drinking water in future. But I really see, I think especially with the zero maintenance piece, I think there's a real niche there in the wastewater side of things as well, as much as I enjoy the drinking water kind of things. So SENTRY, I think the thing that drew me to this specific technology in QCL is because I really like the online aspect. I really like the dashboard. I like how you can bypass it if you want to and use SCADA instead. I think the zero maintenance for me, coming from my background coming from the equipment that I've used in the past, I think that's another real big attraction for me. And we spoke a lot about yesterday in the talks yesterday, about acting proactively rather than reactively. And this is something I really hope to achieve with this work. I think I've got a lot of work to do, and I think there's a lot of future trials that I can do, but I'm really interested in getting feedback, comments, solutions, ideas on how we can make this equipment even better and how we can kind of apply it to some problems that you might have out there. This is our team. So you might have seen Patrick, you might have seen Pat. So he is the brains behind the operation. He is the CEO of SENTRY. He designed the equipment, and he's the reason that we're here talking about it today. We've got Tom, so he, of course, is in the room. If you want to talk about anything to do with instrumentation, he's got a wealth of experience. Really recommend you talking to him about literally anything. He'll be able to have a chat with you on that. And he manages SENTRY in terms of its international applications. And I'm Natalie. I do all the UK project management side of things, so I'm the person who will be ringing you, emailing you, doing all the site visits, spending a lot of time on site. And I work with QCL, and we provide microbial solutions in brewery, dairy, and in water as well. So my talk today has been real time, so 1 reading a minute, microbial performance monitoring, a Fitbit for biology, in wastewater treatment systems, so when submerged in water sources. Thank you very much for listening to me talk today.